Welcome, recruits, to the Shape Detective Academy. I am absolutely thrilled to have you here for a brand new explainer where we're going to uncover the hidden geometry in our world. If you're in year 3 and you are ready for a real adventure, well, you're in the exact right place. Because today, we aren't just learning about maths. No way. We're training to see the world completely differently. So, are you ready to spot the secret shapes hiding right in front of you? I want you to literally look around your room right now because shapes are everywhere. You might think a door is just a door or a window is just a window, but a trained shape detective, they know those are actually rectangles and squares. By the end of this explainer, you're going to have this special maths vision that lets you spot hidden shapes wherever you go. Section 1. Shapes in our world. Let's jump right in and see how builders use shapes to create the cities we live in. We're starting big.
Check out the tall buildings and houses here. Go ahead and shout out what different 2D shapes you can see hidden in the design. Do you see those beautiful houses right in the front? Look closely at their roofs. What shape makes that pointy top? Yup, a triangle. Now look way up at those tall, towering skyscrapers in the background. They're basically made of hundreds of long rectangles stretching right up into the sky. It's like a giant puzzle. Builders are really just master shape detectives who use these shapes to build everything around us.
Now, to be top-notch detectives, we need to add some really important maths words to our toolkit. You can't go on an investigation without the right tools, right? So let's read these out loud together. Ready? 2D shape, 3D shape, square, symmetrical, face, rectangle. Honestly, if you can master these words, you'll be able to describe pretty much any object you find in the entire world. Let's crack the code and figure out exactly what these mean.
Moving to Section 2, 2D versus 3D shapes. Get ready for something I call the pickup test. Understanding this difference is absolutely crucial. It's your first major milestone here at the Academy.
So, the biggest clue we have is this pickup test. It's super simple. We literally cannot pick up a flat 2D shape, but we absolutely can pick up solid 3D shapes. Think about it like this. If you draw a square on a piece of paper, you can't pinch that square and lift it right off the page, can you? Of course not. It's completely flat. That means it's two-dimensional, or 2D for short. But if you have a square building block, well, you can grab it, hold it in your hands, turn it all around. That makes it a solid, 3-dimensional, or 3D shape. Now, when we hold a solid 3D object, those flat parts on the outside that we can see and touch, those are called faces. And here's the wild part. These faces are actually 2D shapes. It really shows us how 2D and 3D shapes work together as a team. A 3D shape is basically built out of flat 2D faces. If you look at a solid box, the flat side you can just slap your hand against, that is its face. And that face is usually a 2D rectangle, or maybe a square. Let's put this into practice. Take a look at these objects: the tennis ball, the boxes, and the can. Which of these 3D shapes can you name? And what 2D shapes can you spot on their faces? Let's use those new detective skills. See that yellow tennis ball? It's perfectly round. That's a 3D shape we call a sphere. What about the orange box right next to it? Every single face on it is a square. Can you guess what that's called? Yep, a cube. And check out that shiny metal can. If you look right at the top face of that can, what flat 2D shape do you see? It's a perfect circle. All right, Section 3, faces, curves, and angles. It is time to start spotting some serious clues. Looking back at our city, can you list any shapes with right angles? Or maybe find shapes that are perfectly symmetrical? Let's pull out our toolkit again. A right angle is like the perfect sharp corner of a piece of paper or a book. If you look closely at the windows on those houses, you are going to see right angles everywhere. Now, what about the word symmetrical? That just means if you drew a line straight down the middle of a shape, both sides would match exactly, kind of like butterfly wings. Look at that middle house with the blue paint. If we hypothetically sliced it right down the middle, the left side and the right side would be identical reflections. That is symmetry in action, my friends. We can actually organize our whole investigation by listing the 2D shapes we found under these specific headings. Because let's face it, top detectives have to be super organized. Let's imagine sorting the shapes we just found. If we found a triangle on a roof, well, it has 1, 2, 3 sides. 3 is an odd number, so boom, it goes right in the first column. If we found a square window, it has those perfect, sharp corners, so it goes under has a right angle. And if we found a round clock face on a building, That would go under has curved sides. See how easily we can just sort the world around us? Moving on to section 4, comparing colorful shapes. Let's practice with a whole bunch of colorful, mixed-up geometry. We're stepping into the training room now.
Take a very close look at this incredibly colorful puzzle here. Go on, shout out how many different shapes you can identify. Wow, okay, this is a real challenge. I see a bright green circle down at the bottom left. Oh, and I see a big purple shape with 1, 2, 3, 4, 5, 6 sides. Do you know what a 6-sided shape is called? That's right, a hexagon. I even see an orange shape that looks kind of like a circle cut perfectly in half. There are triangles, squares, and rectangles just stacked all over each other like a crazy pancake breakfast.
Now I want you to choose any 2 pairs of shapes from that colorful puzzle. Use your brand new mathematical words to describe what is the same and what is different about them. Let's do an example together, just to warm up. Let's take the red triangle at the top left and compare it to the big yellow square right in the middle. So, what's different? Well, the triangle has 3 sides and the square has 4 sides. The square has those perfect right angles, but the triangle's angles are much sharper. Okay, what about what's the same? Well, they're both completely flat, which means they are both 2D shapes. Being able to compare clues like this is a true master detective skill. Finally, section 5, the classroom shape hunt. This is your real-world mission, folks. Get your magnifying glasses ready. If you look around your classroom or your room at home right now, what real objects do you see that would belong under curved surfaces? And which ones belong under flat surfaces? Let's look closely at your desk or a table. Is it curved and bumpy or perfectly flat? Most likely, your desk belongs firmly under flat surfaces. Now, look for something like a globe, a football, or even just a water bottle. When you run your hand over them, your hand actually has to bend, right? That means those objects have curved surfaces. I want you to try and name at least 3 objects for each column right now in your head. Go on, I'll wait a second. All right, for your final mission in this explainer, I'm challenging you to explore your building today and find 3D objects with circles, squares, or rectangles as faces. Can you find a cabinet with rectangular faces? Maybe a dice with square faces? What about a clock that acts as a big circular face on a wall? You see, shapes aren't just boring things drawn in a textbook. They are literally the invisible building blocks of our entire universe. So, shape detectives, my big question for you to take away today is this. Now that your maths vision is officially turned on, will you ever be able to look at your classroom the same way again? Keep your eyes peeled and keep exploring.